All right. We talked about transforming any function. What about non-functions? So we got to be a little bit careful here, but of course they do transform just like anything else. But we do have to be careful. Let me explain a couple quick things. First of all, we've got y equals x minus h squared plus k. I'm going to ignore the stretch factor for now. Notice that I can write this as y minus k equals x minus h squared. In my classes, we always write this first one because when we're typing it into the calculator, and we do a lot of this kind of exploration, it's a lot easier to have it in y equals form. You will see this written quite regularly, the y minus k and the x minus h. And the reason I bring this up is let's take a look at a circle of radius 4. So if I were to graph this, it has a center at 0, 0. It's got a radius of 4. And let's say I want to transform it. Well, what I'm going to do is I'm just going to say, hey, I replaced x with x minus h. That's how I shifted things left and right. I'm going to replace x with x minus h. And if I look up here, I discover that I also replaced y with y minus k. Now notice that that's in the alternative form, so I'm just going to write y minus k squared equals, now, stretch factor. Stretch factor is sort of built in here. We had 16, that told us radius 4. I can't stretch in the x direction or the y direction alone because then I don't have a circle anymore. I've got an ellipse. So if I'm gonna stretch, what I've got to do is I've got to change the radius. And so, we'll stick this stretch factor over here. Actually, you know what? I'm going to do? I'm just going to leave this a circle of radius 4. If you want to stretch it or compress it, you're just going to change that. You're going to change that r squared term in the circle. So again, notice that I take x and I turn it into x minus h. There's a horizontal shift. I take y and I turn it into y minus k, and there's my vertical shift. And then stretch factor, not going to deal with it too much here, but you can play around with that and figure it out. All right. So then one other that comes up in our course is piecewise functions. And piecewise functions are pretty straightforward, but there is one thing you have to be really careful of. So let's look at a quick piecewise function. Hopefully you know what that is. Could look something like y equals x squared minus 5 from negative 3 less or equal to x less or equal to 4. And so there's x equals 4 right there. And then, oh dear, I've messed myself up here. So I've got 16 minus 5 is 11. I need some linear function, mx plus b, for 4 less or equal to x, less or equal to, say, 7. And whatever that is, we're just going to assume that they meet up right here. So whatever m and b are, they're gonna equal 11 when x is equal to 4. Irrelevant for the purposes of our discussion. So how do I shift these functions? Well, let's say I want y shifted vertically by plus 5. Well, it's really simple. I just say, well, then y is equal to x squared minus 5 plus 5. And I say mx plus b plus 5. I might as well write minus 5 plus 5. And nothing else changes because all I've done is I've just shifted everything up by 5. And it still goes from negative 3 to 4. And this still goes from 4 to 7. And it's just sort of irrelevant. Well, here's where you got to be a little careful, because what if I want to take y and I want to shift it to the right by 3? Well, this becomes y equals x minus 3 squared minus 5. But notice it's not between 3 and 4 anymore. It's between 0 and 7, because I just moved everything over. Whichever direction it is. I don't know. I'm backwards. M times x minus 3 plus b, but I'm not going to be between 4 and 7 anymore. I'm going from 7 to 10. So when you're doing a horizontal shift on a piecewise function, it's really, really important that you also shift your boundaries of your piecewise function. And of course, stretch factor, obviously, don't have to. Plug in an A in there, doesn't make any difference at all. Okay, there we go. Thanks for watching.